The steps for solving cubic inequalities are very similar to solving quadratic inequalities. We move all non-zero terms to one side, then we factor completely and find solutions. Then we plot solutions on a number line and test a point in each interval. So example 1, solving graph x cubed minus 25x less than or equal to 0. So to factor this particular equation, we'd start by factoring out an x from both terms. So factor out an x, that would leave x squared minus 25 less than or equal to 0. But now we want to continue factoring. So x squared minus 25 is the difference of squares, so we can factor it to x plus 5 times x minus 5. And we still have the x that we took out as the GCF initially. And now we can find our three solutions for this cubic equation. So the first solution, we set this equal to 0, x equals 0. The next solution, set x plus 5 equals 0. Subtract 5 from both sides to get x equals negative 5. Third solution, set x minus 5 equal to 0. Add 5 to both sides to get x equals 5. So we have three solutions to this cubic inequality, or three solution points. And we'll plot those in order on the number line. So negative 5, 0, and then 5. So really the difference with cubic is that we potentially have more solutions on the number line and therefore more intervals to test a point in. So first let's test a point to the left of negative 5. Let's test negative 6. And if you recall from quadratics, we can test our point in any form of the equation. So we could choose this form, or this form. Okay, let's test it in the factored form. So that would be plugging in negative 6 for x. We'd get negative 6 times negative 6 plus 5 times negative 6 minus 5. We want to know if that's less than or equal to 0. That's negative 6 times negative 1 times negative 11. That is negative 66, which is indeed less than or equal to 0, which means that the interval containing negative 6 is part of our solution set. Now let's test a point between negative 5 and 0. Let's test the point negative 4. That would be negative 4 times negative 4 plus 5 times negative 4 minus 5. We want to know if that's less than or equal to 0. That would be negative 4 multiplied by positive 1 multiplied by negative 9, which is positive 36, which is not less than or equal to 0. Therefore, this area is not part of our solution set. Now we'll choose a point between 0 and 5. Let's choose the point 1. Plugging into the factored form, that would be 1 times 1 plus 5 times 1 minus 5. We want to know if that's less than or equal to 0. This is 1 times 6 times negative 4, which is negative 24, which is indeed less than or equal to 0. So this region is part of our solution set. And finally, we want to choose a number to the right of 5. So let's choose the number 6 and test that point. That would be 6 times 6 plus 5 times 6 minus 5. We want to know if that's less than or equal to 0. That's 6 times 11 times 1, which is 66, which is not less than or equal to 0. Therefore, this is not part of the solution area. So our solution is everything less than negative 5 and everything between 0 and 5. Now we consider what type of endpoint. So since our inequality is less than or equal to, these endpoints are included. So on the graph, we draw a square bracket at each of these points. So now our solution region is negative infinity to negative 5, and including negative 5, union 0 to 5. First step to solving these inequalities is to move all terms to one side, then to factor, then to plot the solution points, and then to test a point in each interval. So solve this inequality and graph the solution set x plus 2 multiplied by x squared plus 2x minus 15 greater than 0. Everything's already on one side, so now we want to factor. X plus 2 is already completely factored, but we can factor x squared plus 2x minus 15 further. So we look for the numbers that multiply to negative 15 and add to 2. Those two numbers are positive 5 and negative 3. So this factors to x plus 2, and then those two factors for negative 15 are positive 5, negative 3. So x plus 5, x minus 3. And now we solve. So set each of these factors equal to 0. The solution for this first one would be x equals negative 2 after setting x plus 2 equals 0, x equals negative 5 after setting x plus 5 equal to 0, and x equals 3 from setting x minus 3 equal to 0. Now we plot those three solutions in order from least to greatest. Now we want to choose a test point in each interval, so something starting to the left of negative 5, let's choose negative 6. And we could use either this form or this form to test the points, but let's use the factored form. That would be negative 6 plus 2 times negative 6 plus 5 times negative 6 minus 3. We want to know if that's greater than 0. This is negative 4 times negative 1 times negative 9, which is negative 36, which is not greater than 0. So this is not a solution area. Now we choose a number to the left, or in between negative 5 and negative 2. Let's choose negative 3. That would be negative 3 plus 2, negative 3 plus 5, and negative 3 minus 3. We want to know if that's greater than 0. This is negative 1, positive 2, and negative 6. Multiplying those together, we get positive 12, which is greater than 0. So between negative 5 and negative 2 is part of our solution area. Now we choose a number between negative 2 and 3. Let's choose 0. 0 plus 2, 0 plus 5, 0 minus 3. We want to know if that's greater than 0. This is 2 times 5 times negative 3, which is negative 30, which is not greater than 0. So this is not solution area. Finally, we choose a number to the right of 3. Let's choose the number 4. 4 plus 2, 4 plus 5, and 4 minus 3. We want to know if that's greater than 0. 6 times 9 times 1 is 54, which is greater than 0. So this is our solution area to the right of 3. And now, since the inequality is greater than and not greater than or equal to, that means the endpoints that we plotted, these endpoints, are not included, so we use parentheses on the graph. And now writing our solution set, we have all of the area between negative 5 and negative 2, which we write as the interval negative 5 comma negative 2, with parentheses because negative 5 and negative 2 are not included, union the interval starting at 3 and going to the right towards infinity.